Hi, this is Mr. Erlin, ready to talk about solving a triangle with the law of sines. This is a form of using trigonometry to find missing parts of a triangle that's not necessarily a right triangle. So here I'm looking at a scenario where I'm given an angle and two sides, and they're in the ASS environment. In other words, it's not trapped between the two sides. I always recommend that we label our triangles, and then we can label the corresponding sides because the opposite sides are labeled with the same lettering but the lowercase instead of the uppercase. And then I create a little table. I want to find A, B, and C, which are the angles, and A, B, and C, which are the side lengths. I'm already given A is 40 degrees. I'm given that C is 8 units long and that A is 10 units long. I need to find lowercase b, uppercase C. So I'm going to begin with the law of sines. You remember that the law of sines says that the sine of angle A is to A as the sine of angle B is to B is the sine of angle C is to C. So I notice that I've got A and A. I've got a pair that matches to give me a ratio. So I'll start with the sine of 40 degrees is to 10 and I'm going to solve this one first because I've already got its side. So the sine of C is to 8. I'll solve this as a proportion by cross multiplying. I'll get 10 times the sine of C is equal to 8 times the sine of 40. Divide by 10. And I get that the sine of C is equal to 8 sine of 40 over 10. To find the actual value of C, I'm going to have to inverse sine both sides, or arc sine. And I get that C is the arc sine of 8 sine of 40 over 10. I'm going to plug this into my calculator, making sure that my calculator is on the degree mode. It's on degrees. And I'll say second sine, 8 times sine of 40 divided by 10. And I get 30. So C is approximately equal to 30.946. I'll write there's 1,000. And that fills in for me up here. And now there's no way I can get to the length of B unless I knew the angle of A. Angle of B. But I do know that. Because if I look here, I can see that with this angle being 40 and this angle being 30.96, so far I've used up 70.946 degrees. If I subtract that from 180, I can see that the measure of angle B is equal to 180 minus 40 minus 30.946. So the measure of angle B is equal to 109.054. And with that value, I could now plug in to find B. Right? I could set up the sine of 40 is to A again as the sine of our new B angle is to our unknown B. Cross multiply and solve. I can get that B times the sine of 40 is equal to 10 times the sine of 109.054. And this time I'll have to divide by the sine of 40. I'm solving for B, so I need to get rid of what's being multiplied by B. And I can simply plug that into my calculator. 10 times the sine of that divided by the sine of 40 is about 14.705. B is equal to 14.705. Does that make intuitive sense to me? Well, my smallest angle is 40 degrees. My smallest angle is 30 degrees, opposite 8. My middlest angle is 40 degrees, opposite 10. And my largest angle of 109 is opposite 14.705, the largest angle. Now, I can also look at doing what's called the ambiguous case. In this particular triangle, I just discovered that 8, 10, 40, A, B, C, A, B, C. I was able to find or solve the triangle once. If this is the ambiguous case, then what we're wondering about is what happens if this side actually swings over like this, so that it's still 10 units long, but now it's over in this direction. What we had found was that angle C was 30.95. And in fact, if this triangle were to swing around, because it would still be angle side, side, these two sides would still be congruent. They're still 10, which would make this triangle isosceles. So this would be 30.95 as well. What that tells me then is that this angle inside here would have to be 180 minus 30.95. And if I do that, what I end up with is 149.05. So in other words, if this angle were 149.05, then this would be 30.95 because they're supplementary. And the question is, does this triangle exist with this angle? If this were 149.05, and we know that this was 40, I'm already over the 180 that I know a triangle has to have. Therefore, there is no second triangle. Although this was the ambiguous case, the solution for the triangle is just these original values. There is no second scenario.